As prominent quantum physicist Richard Feynman once said, if you think you understand quantum mechanics, you don't actually understand quantum mechanics. My name is Shane Christensen. I'm a biomedical science major at Texas A&M University, and I've taken numerous courses over quantum physics as well as traditional classical physics. And today, we will be going over what are quantum mechanics at a basic level, how can we use these particular subatomic qualities to our advantage, and then once we actually have this power, what can we use it for in society and what problems can we solve? So let's take a step back first and look at what does a normal computer use. Computers use binary 1s and 0 bits. Now these get the job done and are stable for what we use at a day-to-day level, but there's another type of bit, a quantum bit, which is superimposed. So what does this mean? So Che and Associates talks about how they published a journal in 2024 discussing how qubits are superimposed, meaning that they are both the 0 and the 1 at the same time. Now this is very hard to wrap your head around, but it allows for two different parallel modes of processing and computational ability, whereas a traditional computer could only get one because of the binary 0 or 1. Now this is very important because it can allow for holding a lot more data. But this is improved even more due to the idea of quantum entanglement. And as Fang published in a 2023 journal, this quantum entanglement, as seen in the picture here, means that when one is affected, the entangled qubit is also instantaneously affected at the same time. This allows for insanely quick processing that is unmatched by any other systems known to man. So, with such small subatomic particles, how do we do construction or build these devices that can even use this? Well, that's made up through microscopic engineering. So we use these things called hardware platforms. These can be ions or they can be uncharged atoms, and these platforms are used to make stable qubits out of. So this is all very, very small scale here. And once you have all these qubits, these stable qubits built, you can put them through a processor to shoot microscopic lasers and build arrays of qubits that form these quantum gates. And these quantum gates, you can think of these equations as being the quantum version of an electrical circuit, and this is really what holds all of the information. And this is all research that is published as of 2020 by Henriette and her colleagues. So now let's go into think about, well, if they're so small and need such precise equipment, they must be very delicate. And that's right, they are very delicate. That is one of the biggest hurdles in this entire field of work, is that they are so delicate that excess temperature change, or matter of fact any temperature change, or excess electromagnetic field radiation can actually destroy the information that these qubits are holding. And this is a thing called decoherence. And this is also why all of the research done right now to further quantum mechanics and how we process with such information is actually done at near absolute zero, which is very difficult to achieve. So now, what is the point of going through all these hurdles for this information? What can we do with it? There is a plethora of information that can be used for so many different kinds of research. One very prominent one is actually in formation of life-saving pharmaceutical medicine. With the quicker response times and computational ability, we can do so much more research way more quickly on very specific, difficult to research things such as molecular interactions for pharmaceuticals. And this same molecular interaction technology can be used to make solar panels more efficient and help battery lives become extended. So this is good for not only the environment, but for energy conservation. And then now let's get into how this can actually build upon itself. You can join quantum networks with other networks to build a kind of like a hive mind that exponentially increases the computational power. So this is research of Norzer and his colleagues in 2025. And another good aspect of this is that it actually allows for a built-in, which you could say, kind of protection of data. It's protected by quantum physics when there are multiple networks combining, so this information can't be decoded by entities that are not the intended receiver. So all very interesting stuff. And so now that we've gone over the basics of quantum mechanics, how we even start to do construction at something so small scale, and what this technology can really be used for in society. So even though it's still mysterious, we should still use it and continue this research to better society and solve problems that we couldn't with traditional computational models.